Hello everybody, welcome to the video. Today we're going to be going over how to factor polynomials using the method of GCF, or greatest common factor. Okay, so first of all, what does it mean to factor polynomials? I'd like to answer that question. Basically, what factoring is, it's the opposite of multiplying. Okay, so with factoring, you're seeing what divides each number or each term is what you're doing. So for example, if I was asked to factor 15, what that would be is you're thinking of all the numbers that divide into 15, right? So those numbers would be, so 15 would be equal to 5 times 3. That would be factoring. It'd be going from here to here, as opposed to multiplying, which is going from here to here. That would be multiplying. So you can think of factoring as kind of like the opposite of multiplying. These are all the steps for factoring polynomials. Feel free to pause the video and write them down, but the steps are going to be listed on the left-hand side as we do all the examples, and then on the right-hand side, we're going to work out how each of these are done. Okay, so let's begin with this example. As you can see, the steps are right here, and we're asked to completely factor this term, 6a cubed minus 24ab squared. So how are we going to do that? Okay, everyone, here's how we're going to do it. So step 1 is to write out each term. So that's what I've done right here. The first term is 6a cubed, and the second term is negative 24ab to the fourth. These are the two terms. Step 2 is to factor each coefficient. Now remember that a coefficient would be the number multiplied by the variable. So for the first term, the coefficient is 6, and for the second term, the coefficient is negative 24. Okay, so first of all, we can factor 6, that's going to be 2 times 3, and then we also have to factor negative 24. Okay, now it might be helpful to do a factor tree, but this is what you should get. This is why we reviewed factoring regular numbers. So negative 24 would be equal to negative 2 times 2 times 2 times 3. Okay, so like I mentioned, if you want to do the factor tree to help you figure out what that is, that might be helpful. But the first thing you got to do is just kind of factor each coefficient like this, okay? The next step is that we have to expand each variable, okay? So we've taken care of the 6 and the negative 24. We've broken down into its primes. Now, what about the variables? What you have to do for the variables is basically just expand them. So this is what I mean. Here we have a to the third power highlighted in blue, and a to the third power would just be a times a times a times a, right? So here we've completely factored this term. 6a cubed would be 2 times 3 times a times a times a. For the second example, we have an a and we have b to the fourth power, so that's going to be a times b times b times b times b. So we've completely factored the second term as well. So the reason why we want to completely factor these is because for step 4, we want to identify the primes that the terms have in common, okay? So as you look at all these numbers and these numbers, which numbers do they have in common? They have a 2 in common, okay? They have a 3 in common, so I've circled those. They have an a in common, and it looks like that's it, because here there's 2 a's left over and there's no a's down here. So these are all the terms that they have in common. So once we've identified those, what we want to do is multiply those terms together and write what's left in parentheses. So here's what that looks like. The terms that they have in common are 2, 3, and a, okay? And so what we're going to do is write down here 2 times 3 times a. Then what we're going to do is open up a parentheses and write what's left over. So what's left over here is a times a, that's going to be a squared. For the second term, what's left over is a negative sign, so we put that there. 2 times 2 gives you 4. And also, b times b times b times b is left over, so that's going to be b to the fourth power, okay? We can also write 2 times 3 as 6. So 6a would be the highest common factor we can take out. So this is going to be our solution, okay? We've taken out a 6a. We realize that that's what they have in common, and what's in the parentheses is basically what's left over. And notice that in your answer, when you distribute 6a, when you multiply 6a times these two, you will get the original polynomial. So that's important to understand. So when you get your example, or excuse me, when you get your answer, make sure that it is actually equal to the original problem that they gave you, okay? Okay, everybody, so one more example here where it's a trinomial. Once again, we want to factor using the greatest common factor. Here we have three terms, 1, 2, 3, and the first step is just going to be to write out each term. Okay, so let's go ahead and do that. So we have 32x cubed, y cubed, negative 32x cubed, and negative 8x. Then we want to factor each coefficient as much as we can. So the coefficients are 32, negative 32, and negative 8. So go ahead and make a factor tree for those. And what you should get are these. So 32 is 2 times 2 times 2 times 2 times 2. And you don't want to put them as exponents because then you wouldn't be able to circle like what's in common. Negative 32 would just have a negative sign right here. And negative 8 would just be 2 times 2 times 2. And remember, the way I got these is just by using a factor tree, like we did in the previous homework. Then we want to expand each variable, so let's do that one term at a time. So these are the variables. In the first term, we have x cubed and y cubed, so that's going to be 3x's right here, 2y's right here. For the second term, we have x to the third power, that's x times x times x, and then here there's just a 1x. And after we've expanded all that out for the coefficients in red and for the variables in blue, what we want to do is identify the primes that the terms have in common, okay? So actually, that's going to be this step right here. So actually, there's a lot of 2's that these terms have in common. So there's 3 2's, 1, 2, 3, 1, 2, 3, 1, 2, 3. There's no more 2's here, so we don't circle these two. Even though there's some terms in common here, they're not in common with the last one, okay? So in terms of the coefficients, the primes they have in common would just be 2, 2, and 2. And in terms of the variables, it would just be x. So this one just has an x right here, and these two also have an x. So even though these two also have an x in common, there's no more x's here to grab from. So those are the primes that the terms have in common. Then what we want to do is multiply those terms together and write what's left in the parentheses, okay? So here we have the coefficients, 2 times 2 times 2. It's going to be right here. And the variable is going to be x, okay? And what we can do at this point is actually just realize that 2 times 2 times 2 is going to be equal to 8. So we can write that as 8 with an x right there. And then once again, we write what's left in parentheses. So in the first term, what's left is 2 times 2, which gives you 4, which I'll write there. And we also have left over x times x, which is x squared. And we also have left over y times y, which would be y squared. So this is what's left over for the first term. For the second term, what's left over is a negative sign, and also 2 times 2, which is 4. We also have left over x times x, which is x squared, and that's it for the second term. For the third term, the only thing we have left over is a negative sign, okay? And there's also a factor of 1 that's left over. So what we're going to do in terms of what's left over is just write the negative 1, okay? So that's going to be your answer right here. We take out an 8x, and then we have this as what's left over, okay? And notice that if you take the 8x and distribute it to all these three terms, you get the original polynomial, okay? So that's how to factor polynomials using the method of greatest common factor.